Unit 5, Part 8 will now discuss the short truth table method for testing an argument form for validity. Short truth table method is discussed, pages 86 through 89 of Klenk, and you will need this for exams, possibly this one and certainly for later exams. Okay, so I will run through two examples for you. We'll start with 3D and then I will do 3A, doing them in this order for a reason, you'll see. Okay, so short truth table method. Remember that using the full truth table method, the number of columns we have is determined by how many sentential variables we have. Okay, so imagine you were asked to test this argument form for validity, right? You've got this formula, this conditional, comma, this biconditional, comma. Hope you can recognize the major operators there, see them for what they are. This biconditional, and then this conclusion, right? You would list each horizontally across, each formula horizontally across as the headings of columns, and then you would count your sentential variables to see how many columns you're going to have. Okay, I've got a P, I've got a Q, oh, I've got an R, I've also got an S, P, R, I've got a T, my goodness, S, T, got those, had the S, had the T, P, T, had those 5 variables, P, Q, R, S, T. So you'd have to list in alphabetical order P, Q, R, S, T. How many columns, how many rows is my truth table going to have? Right, 5 variables, so to exhaustively list all the possible combination of truth values, I'm going to need 2, 4, 8, 16, 32 rows. Okay, it's going to be a very elaborate truth table. The short truth table method is useful in these situations, especially, right, when actually constructing a full truth table method would be quite cumbersome and laborsome. The idea is, what I'm going to do, remember from the full truth table method what you're trying to do, you're seeing if any counterexamples exist. And you have answered the problem if you found one row, right, any row where all the premise is true and the conclusion is false. Such a row is a counterexample, right? That is such a counterexample, that is an assignment of truth values to the sentential variables which make the premises true and the conclusion false. What the short truth table method is, in essence, is seeking to hone in on a particular row of the full truth table, right? That is seeking to hone in on a particular assignment of truth values to the components which make the premises true and the conclusion false. Okay? So we're not going to draw up a truth table here. Instead, we're going to do this. We counted our sentential variables. What we're going to do is list them in a box over here, right? And when you're asked to do this, here and in later exams, this is how I want you to answer it. Draw up a box for me, right? P, Q, R, S, T, right? So you're listing all the sentential variables equals, and what we're going to fill in here on this side, this is to be determined, we're going to put truth values here. So P is going to be T or it's going to be F. Q, T, or F. And we're going to slowly, I'm not sure which one's going to appear first. I'll show you how that's determined. But we're going to put T's and F's here. And what we want to construct, what we're trying to hone in on, is a particular assignment of truth value. This box is going to present me with a counterexample, if it is possible to find one. Right? I'm trying to hone in on a counterexample, that is, an assignment of truth values to these sentential variables, which make the premises true and the conclusion false. And if I can construct such a counterexample, right, if I can get something, in the end it's going to appear something like T, F, F, T, T, or something like that, right? And if that assignment of truth values is, as I must have shown it to be, such that it makes all the premises true and the conclusion false, it will be like, right, it will be as if I have found a particular row on the truth table, right? Say, let's just say it's true, 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 true. Right? Everything is true. That makes the premises true and the conclusion false. It would be like me finding the first row and pointing to it and saying, look, that's the counterexample. Right? Whatever that assignment of truth values is, matches one row in a truth table, of course. Right? Because what are the rows? Right? Each row is an assignment of truth values to the sentential variables, and all the rows exhaustively list all the possible combinations. This is the combination, that is the row that would appear on the full truth table, where the premises come out true and the conclusion false. Okay, so that's what I'm looking for. Now, we begin like this. Let me notice a contrast. When we computed the second premise, the disjunction of P and not Q, right? We had to work from the subformulas. In computing the truth value, we had to work from the subformulas up to the truth table column under the major operator, right? So we worked bottom up in that subformula first, and then all the way up to that. And Klenk's examples on 80 and 82 have more complex formulas with more subformulas, and you'll see how she goes through it there, right? You've got to work out the subformulas in order to determine the truth value of the major operator, be it a hook or wedge, whatever it is. We do it differently here. Notice the contrast here. We're setting ourselves the task of finding the truth value assignment, right? Over here, we started with the truth value assignment. For each row that we're calculating, we have the assignment of the components, and then we calculate the premises and conclusion. This is different. What we do here is, this is undetermined. What row it is in the full truth table where we're going to find is undetermined. That is what we're going to get to. That's our goal. Right? That's what we're seeking. We're seeking the truth value of the simple components. Here, whereas the truth table computing, that was bottom up, as I said, this is going to be top down, right? Because what am I doing? I'm trying to construct a counterexample. I'm trying to find an assignment of truth values that makes all the premises true and the conclusion false. So I start with the truth value assignments of the premises true and the conclusion false. That is, I go straight to the major operator of each premise, and I put a T there. T under the hook. You have to be able to see by now that that is the major operator for this. This is a conditional where the antecedent and disjunction and consequent are both disjunctions. It's a conditional where the antecedent and consequent are both disjunctions. What's this major operator? It's the biconditional. I make this true, right? I assign T to the major operator. Don't know what's here, don't know the truth values of these yet. That's what I'm going to try and work out. Third premise, I got three premises, notice, here. And what else? Take note of this part. I'm assigning, what truth value assignment am I going to assign the conclusion? That's right, false. I want a counterexample. That is, an assignment of truth values to the parts that make the premises true and the conclusion false. And it's top down in this way. Short truth table method is top down in this way, right? I've assigned these, and now I'm going to see what follows from that. And so this is the overall frame, which is crucial. If I can, so this is the really crucial statement. If because it is a test of the argument's validity, and I don't know yet whether it is or is not, and some of these ones in question 3 will be shown valid, and some will be shown to be invalid. I've made that assignment of all premises true and conclusion false. If I can find an assignment of truth values to the component to make that true, right, that is consistent with this assignment. If I can find an assignment of truth values to the P's and Q's, right, fill in this box, which is consistent with what I've already done, right, which makes the premises true and the conclusion false, then, if I do succeed in finding this, then the argument is invalid. I've presented a counterexample and it is invalid. But if I cannot, it might turn out, this will happen in 3a, right? It might turn out that it is not possible. I'm stressing this because this is the theoretical frame you have to have in mind to know what you're doing when you're doing this. If it is not possible for me to find assignment of truth values to the P's, the Q and the RNS consistent with what I've already done, right? That makes the premises true and the conclusion false. What will my conclusion be? Is my conclusion I've made a mistake? No, not necessarily. I might have made a mistake, but no, if I've not made a mistake, the conclusion is, this is a valid argument form. It is not possible for me to construct a counterexample, right? So no counterexamples exist. It's a valid argument form. Okay, that would be the correct conclusion. Okay? All right, so I will come back in the next part and actually start on it.